Okay, so now that we're done with that, I'm going to show you a few formulas that are very useful when it comes to dealing with a series. So in the previous one, we just did this simple question. Okay, so what are these formulas? Right? What are these formulas that we're going to be dealing with? First one is, I always forget the name of this, so let me check it. You'll never be asked to describe it, but it's very important. It's Euler's constant. Yeah. Euler, whatever you want to call it, Euler's constant, h of n. H of n. This is basically n, right? N, and then we have I starting at 1, right? Of 1 over I. This is equal to, or it's approximately equal to, so it's an approximation, log, right? Log base e of n, or ln n, right? Or ln n, like that. So this is Euler's constant, and this is what we call harmonic numbers, right? And then two other representations, which are just basic algebraic formulations. I don't really need to explain them. Well, I think I did explain them last year, but yeah, if you haven't watched any of my previous videos, I can just explain them. First one is n being a summation starting at I being equal to 1 in the form f of n, right? This is basically the same as n times f of n, right? Again, this one you can easily solve it. This one can easily be proved. Just basic algebraic manipulation. You can remember it, and then you can just try to wrap your head around it. It's not very complicated. It shouldn't deserve a lot of time. Then the final one is n. So summation up to n starting at I is equal to n naught, right? N naught in the form f of I, right? Now we're used to it starting at 1 or 10, but then let's say we stay at starts at 5, right? How can you then solve this one? Well, most formulas accommodate us starting at 1 or 0. So the way we do this is by solving it in that same form, starting at 1 or 0. So we're going to say n, right? N there being a summation starting at I is equal to 1, right, of f of I minus, right, minus the summation of the summation up to n naught minus 1, right? N naught minus 1, and then we're going to have I being equal to 1 f of I. So now to explain this formula a bit, because it's one that I haven't really discussed with you guys, so I'm just erase what I have here. Just erase this, and then I explain this formula. Okay, so we're going to have that, right? We're going to have that over there, and then basically to explain this is like, let's say I've told you to find a summation, right, of the numbers from 5 up to 10, right? So it would be 5 plus 6 plus 7 plus 8 plus 9 plus 10. In most cases you would have when you're doing this, you'd have like a formula, right? So especially if you're doing with big numbers, because if I tell you to say find the summation from 10 up to 1000, you're not going to do that by hand. You're going to do that by formula. But then usually the formula would accommodate you starting at 1 up to 10, right? So now how are we going to account for these missing numbers over here? Which is basically what we have here. So what we assume is that instead of us trying to bother doing that calculation manually from 5 up to 10, what we do is that we do the entire calculation from 1 up to 10, right, which is this first part over here, but then we erase or we subtract everything before 5, which is why we have n naught. So in this case n naught is 5, so we do this, we subtract the summation up to the number just before 5, in this case 4. So which is what we're going to add. We're going to add 1, 2, 3 and 4. We're going to add those and then subtract them from the summation of the entire thing, which leaves us with just this summation that we want over here, which is basically what that formula means. And yeah, it's going to be very helpful going forward. But given this brief introduction to summations, let me do some sets of questions, right? I'm going to do 3 questions with you guys, and what these would do is that they would show you how to go about most summation problems. Not all of them, but most of them, because there are some that are like proof heavy, and we're going to do those as we keep on going. But again, this is just an introduction to the simple stuff. Okay.